In a triangle PQR, right angle at Q, the value of angle P is equal to X and PQ is equal to 7 centimeters, QR equal to 24 centimeters. Find sin X and cos X. This is a right angle triangle. Right angle at Q, we should take this is the right angle, and PQ is equal to 7 centimeters. So this is PQ is 7 centimeters. QR equal to 24 centimeters. Hypotenuse, we need to find this hypotenuse. So PR square is equal to, we know that PR square is equal to PQ square plus QR square. This equal to PQ is 7 and QR is 24 square. 7 square is 49 plus 24 square is equal to 576. This equal to 625. PR square is equal to 625. PR is equal to under root of 625 is equal to 25 centimeters. This is 25 centimeters. Now the angle P equal to X. Here is the X. We need to find the sin X is sin X degrees is equal to, so what is that? For X angle, the opposite side is QR. Opposite side QR by hypotenuse is PR. Sin theta is opposite side by hypotenuse. So this is opposite to X, QR, and this is hypotenuse. So QR equal to 24 and PR equal to 25. So sin X equal to 24 by 25, and the cos X value is cos X degrees is equal to, cos X is, for angle X the adjacent side is PQ and hypotenuse is PR. Adjacent side by hypotenuse, that is PQ by PR. PQ equal to 7 centimeters by PR equal to 24 centimeters. Sin X equal 24 by 25, cos X equal to 7 by 24. Think and discuss in trigonometry 10th class. Discuss among your friends. Does sin X is 4 by 3 exist for some value of angle X? How can you say? The answer is no, because the value of sin X is always lies between minus 1 and 1 only. But here is 4 by 3 is greater than 1 value. It is equal to 4 by 3 is equal to 1.33. So it is greater than value. The X angle is not exist for sin X equal to 4 by 3. For any real value that X, this is because the sin factors function is range is -1 to 1. This is sine theta lies between -1 and 1. So, and in a triangle, for example, angle, this is angle x, opposite side a b c, this is the opposite side is bc, and the hypotenuse is ac. There is a relation, always this hypotenuse is greater than bc, we know that, greater than bc. So in sine x we can write bc by ac. From this we know, from this ac is greater than bc, therefore the sin x value or sometimes equal to bc also. So sin x value is less than or equal to 1. So it is never greater than 1. So the sine angle is defined the ratio of opposite side to hypotenuse and a right angle at B. Then we can write this sin x equal to BC by AC. So this value is always less than 1, less than or equal to 1. If it is 90 degrees, the x is 90 degrees, then the sin 90 is 1. We know that sin 90 is 1, and also for that, in this, here is a triangle, for sin 90 is 1. If it is in third coordinate, the sin 90 is -1. So always the sin x is lies between -1 and 1 only. So 4/3 is not exist. Second, the value of sin A and cos A is always less than 1. Why? No, the value of sin A and cos A are not always strictly less than 1. Sin A or cos A, the values of sin A and cos A are not less than 1, and they can be equal to 1 sometimes. Specifically, the maximum value of sin A is 1, and the maximum value of cos A is also 1. The sin A range is, we know that, -1 to 1, and the cos A range is also -1 to 1. For example, sin take 90 degrees. What is the value of sin 90? We know that 1. And what is the value of cos 0? 0 is also 1. This is the maximum value of sin 90 and cos 0. But here is given less than 1. Less than 1, I can't agree this. Always less than 1 is wrong. Equal to 1 also there. The values are greater than, not greater than 1, and explained. So from this triangle we explained already that AC is equal to sometimes AB, that means 0 degrees. The AC is equal to BC when 90 degrees. So AC is always greater than or equal to these two sides, but never less than AB less than BC. So the value of sin A and cos A is always less than 1 is wrong. Third one, tan A is product of tan and A. Justify your answer. No, tan and A, tan and A is not separate, is not a product of tan and A. The notation tan A represents this. Tan A represents a single trigonometric function. It is a function. The tangent of A is called, it represents the angle tangent of A. Then tan is not abbreviation, it is not a multiple of tan and A. So it must be applied to angle, then it represents that is tangent. That means A is for angle A, the opposite side and adjacent side, the ratio of opposite side and adjacent side ratio is called uh, tangent. So tan A is not separated. Tan A is a function.